On the left, you have the script, which is going to be analyzed in a minute. In the middle is the familiar looking event loop representation with microtask queues to the right. In the bottom right corner is the console, which will show the output of running this script. This diagram doesn't include the call stack like it did before, because it would decrease readability and unnecessarily further complicate things. Also, it is actually redundant if you think about it. Its operation doesn't alter the order of execution, which you can deduce just considering macro and micro tasks. Starts running in the main thread. Before the event loop even starts, however, the context will execute console.log synchronously on line 3. So, start word gets logged onto the console. Then sets timeout on line 5, adds its callback to the queue for timers phase for the next or first iteration of the event loop after 0 milliseconds. Set immediate on line 6 runs and schedules its callback in the check phase, again for the first iteration of the loop. Then fs.readFile starts reading the file and registers its callback for I/O operation. Note that it doesn't run the code inside the callback just yet. It will do so only once the I/O operation completes. That callback will be executed in the I/O phase, that's the poll phase, in the next iteration of the loop. Then promise from line 14 is resolved and its callback is triggered and registered in the promise micro queue. Process.nextTick on line 20 registers its callback to the nextTick microtask queue. Then another set timeout from line 21 registers its callback to be run after 0 milliseconds in the timers phase. Finally, console log on line 23 is run, no callbacks this time, all synchronous code, so the word end is logged to the console right away. This concludes the initialization phase, i.e. requiring modules, registering callbacks for events, and running the synchronous code. The state of the event loop phase queues and micro queues at this point is exactly as depicted in this slide. Next, the context starts evaluating respective queues. As always, before touching macro tasks, micro task queues are checked first. So first, the process.nextTick. There's a callback there, scheduled by line 20, which has a simple console.log, so nextTick is printed. This callback is popped from the process.nextTick FIFO queue. On to promise microtasks queue. There's one callback there from line 16. Console log promise is called directly, therefore promise is printed. Line below, so line 17, process nextTick gets executed and adds its callback to the process.nextTick microtask queue. This concludes running of the promises micro queue. You might think, hey, there's a new callback there now, and micro tasks always take priority over macro tasks. Shouldn't it get executed right away? It's a valid question, and you'd be almost right. When a micro task is being executed and it schedules another micro task using process.nextTick or a resolved promise, the newly scheduled micro task is executed immediately, before the event loop returns to the macro task queue. This behavior ensures that microtasks are fully drained before the event loop proceeds to the next phase. Because of that, the next tick queue, which has a new callback, will be processed next. Therefore, promise next tick is logged to the console. Now all the microtasks are executed. The event loop starts its first iteration with the timers phase. Here there are two callbacks which were scheduled to run no sooner than after 0 milliseconds, so they can be fired immediately in the order they were queued. Set timeout 1 and set timeout 2. No more timers enqueued, so the loop checks for any microtasks. There are none, so it proceeds to the pending queue, which is empty. Again, the microtask queues are checked for callbacks. There are none, so the loop moves to the poll phase, which has a callback registered. IO event was received, so the callback gets executed. Neither line is executed directly though, so the callbacks are registered in queues for respective phases. Set timeout registers callback in the timers phase, set immediate in the check phase, and next tick in the next tick micro queue. No more IO events. Now, we are presented with a very interesting situation. There is a callback scheduled via process.nextTick, and as you know, microtasks are executed between event loop phases. However, the poll phase is special in the way it can transition directly to the check phase if there are scripts scheduled by setImmediate. And this is precisely the situation we are in. So the loop moves on to the check phase, where it executes the only callback there registered for this iteration of the event loop and logs setImmediate to the console. Once check is completed, the normal service is resumed, a phase ended, so microtasks are checked next. Console log from line 11 is executed and logs read file next tick. Back to macro tasks. Queue for close phase is empty, so the first iteration of the event loop is completed. On to the next one. And we immediately run into another interesting edge case. There are only two remaining callbacks, set timeout and set immediate. Set immediate is intended to execute a script as soon as the current poll phase finishes. Set timeout schedules a script to run after a specified minimum delay in milliseconds has passed. The execution order of those timers can vary depending on the context in which they are invoked. If both are called from the main module, the timing will be influenced by the performance of the process, which can be affected by other applications running on the system. When the two calls occur within an I/O cycle, such as within the fs.readFile callback, the setImmediate callback is always executed first. So, as expected, read file setImmediate gets logged to the console. Now, the primary advantage of using setImmediate over setTimeout is that setImmediate will always execute before any timers when scheduled within an I/O cycle, regardless of the number of timers present. And so, finally, read file setTimeout gets logged to the console. In the bottom right corner, you can now see the complete console output of running that script. To show you this is correct, let's actually run this script in my code editor. As usual, I'll copy the relative path, run the script, and we see in the console the exact same order. Synchronous code got executed first, start and end are here. Next tick micro task got logged, 2 promises, set timeouts, set immediate which run before this read file next tick, and then the last 2 callbacks. So set immediate which run before set timeout, and the last callback which is read file set timeout. Before I end this video, I just want to reassure you a little bit. To get a question like this 100% right in an interview setting is extremely difficult. You need to remember about all the phases, micro tasks, corner cases with timers and IO poll phase, etc. In fact, I was given such task in a real interview and I didn't get it exactly right, but I got the order almost right. The interviewer was actually flabbergasted I did as well as I did. He just wasn't expecting it. It's one of those questions which is so difficult that you are testing the candidate's knowledge as much as their ability to deal with pressure and failure potentially. Another note, always try to look at the script line by line. Looking at the entire thing is very intimidating, but if you draw all of the event loop phases, the micro task queue on the side, and then you take a look at the script, pick out the synchronous code, you start scheduling the callbacks for each phase, this will get much easier and you'll be able to get through methodically the example and potentially get most of the order right.